This question is on Faraday's law and also on Ohm's law, which is what you have learned a few chapters back. So the answer to this question is B. By Faraday's law, the induced EMF and the induced current is dependent on the rate of change of magnetic flux that the wire experiences. So for a straight wire that is cutting through the magnetic field lines, know that the length of the conductor, the length of the wire, the speed of how fast you move the wire to cut the magnetic field, and the strength of this external magnetic field, all this will affect the magnitude of the induced EMF in the moving wire. And the resistance of the conductor does not affect EMF, and this requires you to understand a concept which is Ohm's law. I have always taught all of you that Ohm's law V equals IR, that there is a cause and effect relationship, and resistance is always the most fundamental because it is determined when you construct the wire, the length, the resistivity, the cross-sectional area, all these affects the resistance. EMF is dependent on the power source, the battery, and also on how you connect the circuit, and therefore currents is always the consequence, because it's dependent on two things: the voltage, the EMF and the voltage applied across it, and also the resistance of the whole circuit. These two things will come in to determine what is the currents. Therefore, resistance of the conductor will not affect the EMF, because the resistance is determined by the material of the wire itself. The EMF is determined by the battery. So there are different things, and that's why B is the answer for this question.